name's Steve Zitney. Head up the Process and Dynamic Systems Research Group at the National Energy Technology Laboratory, or NETL for short. The U.S., in terms of coal supplies, we probably have over a 250-year supply of coal based on current usage. So I envision that coal will continue to be an important part of the U.S. energy portfolio, and gasification technology is very well suited to making use of coal, especially in a carbon capture type of scenario. The Department of Energy has an overarching goal to develop innovative gasification-based technologies with 90% CO2 capture, and this project was initiated really to get at that goal in terms of the operations and control of these advanced energy plants with CO2 capture. It's been a collaboration amongst a number of different project partners. I mentioned West Virginia University from the academic side, of course, Invensys Operations Management on software development, and we've brought in a number of consulting partners that have quite a bit of IGCC operations and control expertise. The operator training system was developed using software from Invensys Operations Management. There are a number of packages that have been brought together to deliver the overall OTS for the underlying dynamic model of the plant-wide IGCC, CO2 capture, the power side, the combined cycle side. We've been making use of the DynSim software package. In addition, as part of the OTS system, we have the HMI software, the human machine interface software that the operator trainees will interact with. That was all built on top of the InTouch software, also from Invensys. One thing I like to point out, I think this is the first time we're really bringing together a gasification-based simulator with CO2 capture and combining that with a power simulator, a combined cycle simulator. So it's more or less combining almost a chemical plant with a power plant. The OTS that we've developed as part of this project is a high-fidelity simulator. So we can go through entire IGCC plant startup, shutdown. We can look at what's happening in terms of disturbances, malfunctions, look at load followings. We can do full plant shutdown, including emergency shutdown. We can also look at coal changeover, switchover, so the simulator can handle a variety of different coals, all the way from bituminous coals, subbituminous, up to petcoke as well, and also a number of different biomass feedstocks. So even individual plant sections, for example, the air separation unit, the CO2 captures unit there, we can use those standalone units and really give detailed training and do detailed engineering studies on those specific technologies as well. The dynamics gives you a lot of insights into the overall plant operations, and gain a lot more knowledge beyond just conventional steady-state type modeling that would traditionally be done in terms of designing these systems. In addition to the operator training system, we're also developing a full 3D virtual immersive training system as well, or an ITS, and so that will be a full plant walkthrough type model that will be directly connected to the dynamic simulator, the operator training system, and will allow us to do sort of joint control room and field operator training. So the field operators will be able to walk through the plant in the 3D world and can walk up to a piece of equipment like a valve, close the valve. It will close it in the operator training system, so the engineers working in the control room will see those changes. A lot of the equipment can be made transparent, so you can see what's going on dynamically within a given piece of equipment. And in this project, we're really focusing a lot on the gasification technology, CO2 capture technology, and the ITS will allow us to further highlight those technologies. For example, in the gasifier, we'll more or less be able to look inside the gasifier. You can see animations of the slag flowing down the gasifier that's tied live to sort of the slag viscosity and the underlying dynamic model. So we intend to make use of this simulator in educational settings as well, and senior process design courses, control courses, and this simulator will give us a lot more experience with the operation and control of these systems, and will position us well for the future in terms of using coal systems, and especially clean coal systems where we need to capture the CO2 for storage to avoid the emissions. So I think the simulator is very important in that regard.